Let's see this. Find the number of literals. Find the number of letters in the minimum POS and SYP form for this. So how to solve it is, first thing is they are given you pi. Pi means they are giving you about the product of sums, right? Therefore they are giving you the max terms, not the min terms. So since the max terms are given, I am taking the k map, and in the k map I am representing that corresponding max term as 0. That is the first thing. And now they are asking about both POS and SOP. Anyway, we have to find both POS and SOP. So let me go with the sum of products. Okay, product of sums first. So what are the prime implicants in this? Identify the prime implicants. It is same. We have to identify the subcubes. What are the subcubes here? This is a subcube. This is a subcube. Prime implicant, and even this is also a prime implicant, right? And what are the essential prime implicants? This is essential, because they are not covered by anyone else, right? And this one, the bigger prime implicant, is not essential, because whatever is covered by them, by this, are covered by all the other essential prime implicants, which means by the time you choose all the essential prime implicants, all the max terms have been covered, right? So you need not cover this one, so you need not use this one. So we have only 4 sum terms in this minimal expression. So the sum of the product of sums will be like this. Product of sum will contain 4 terms. What are the 4 terms? One is this one. So if you watch this, w and x doesn't change, right? But and y doesn't change, z is changing. So it is w prime plus x prime. Why w prime x prime? Because they are 1 and 1, that is why. Plus y. For both of them, y is not changing and y is 0, therefore it is y. And product of sums, right? So this is over, this has been chosen. Now let's choose this one. So if you look at this, y and z are not changing and w is not changing. Therefore what do you write? W plus, w is not changing, right? W plus, and here y and z. So y plus z prime, because z is 1. And now I want to take this plus, how can you write this one? In this, w and x are not changing. In this one, w is not changing and y and z are not changing and everything is ones. Therefore w prime plus y prime plus z prime. So it is not plus, it is product, right? Product of sums. And what about next one? This one. See what are the max terms? These two max terms are covered. In these two max terms, w and x are not changing and y is not changing. So w is 0, therefore w, and x is 1, therefore x prime plus, and in these two, y is not changing, y is 1, therefore y prime. So this is the minimum product of sum. What about sum of products? You can put 1, 1, 1, 1, 1, 1, 1, 1, and you can decide. Now if you look at this, all the corners are containing min terms, so all of them can combine to form a subcube. Therefore one subcube is, this is a prime implicant, because it is not contained properly in any other prime implicants, right? Therefore it is a prime implicant. And then this is a prime implicant because it is not contained inside anything. Prime implicant, and prime implicant, right? Now with all these prime implicants, you have to first pick the essential prime implicant. Now I want the sum of products expression. Now what is essential prime implicant in this? It is sure that this is essential, because this one is covered by only one prime implicant. Therefore it is essential prime implicant. So this min term is covered by only that. So if I write this, so what is it? W and x are not changing, therefore w x prime. Why x prime? Because x is 0. When we are talking about the product terms, 1 means true, 0 means complement. When you are talking about the sum terms, 1 means complement, 0 means true. And what is not changing there? Y is not changing, therefore y prime plus. This is over. Now this one, if you choose this one, w and x are not changing, therefore w and x, and both are 1, 1. And then, oh, I am choosing this one, right? So only w is not changing, therefore w, and then y and z are not changing, therefore y z prime plus. This is over. Now I have to choose this one. So in this row, w and x are not changing, therefore w prime x prime, and then y is y is not changing, therefore y plus this one. So if you see this, y and z are not changing and w is not changing. Since w is not changing, I am going to write it as w prime. Why w prime? Because it is 0, w prime, and then okay, what is that I was talking about? I think I am talking about this one. W is not changing, and then y and z are not changing. Y prime z. No, I am not talking about this one. I think w is not changing. Yes, I think I am talking about this one. So w is not changing, and then y and z are not changing. So y prime, z prime. Okay. So these are the min terms. Okay. So these are all the min terms, product terms we got, and this is the sum of product expression and this is the product of sum expression. They are just asking how many literals are there. You can just count them. So what is literal? Literal is an occurrence of a variable either in its true form or complement form. You should count even if it has occurred already once, which means I'll just take an example and show you. See this, w prime has already occurred here and here, but still you have to count it as 2 times. That is how we count the number of literals. So how many literals are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here 12 literals are there. And here 4 into 2, 12 literals are there. Both in POS and SOP form, we have 12 literals, right? But it's not always true for all the functions. We have seen it, right? Both could be different. Okay.